Hello and welcome to Chemistry Solutions. This tutorial is on dimensional analysis. Dimensional analysis is often a tricky concept for students to get, but it's a very important one and one that you'll use throughout all of your chemistry classes. Dimensional analysis is the process we use to convert a value from one unit or set of units to another. Some important questions to ask yourself when doing a dimensional analysis problem are: what are the starting units? What are the units that you wish to obtain? And what are the conversion factors that you can use to get from the starting units to the desired units? In dimensional analysis, you always use conversion factors to get from one unit or set of units to another. And conversion factors are fractions where the numerator and the denominator are an equal quantity expressed in different units. Because the numerator and the denominator are equal, you can also express a conversion factor using its reciprocal. So if 1,000 milliliters is equal to 1 liter, you could write that as 1 liter over 1,000 milliliters, or 1,000 milliliters over 1 liter. Because those two values are equal, the value of the fraction or the conversion factor is 1, regardless of the direction that the conversion factor is written. Let's try a problem. If Tim is 6 feet tall, how tall is he in centimeters? First, let's start with the information given, 6 feet. We know that we need to use a conversion factor, and we know that we need units of feet on the bottom to cancel those units out. And I think it's helpful to put the units that we want on the bottom right away before we even choose our conversion factor. That way we'll write our conversion factor correctly and not accidentally flip-flop it. So let's look at some conversion factors we have available to us. We can see that 1 foot is equal to 12 inches. We already have feet on the bottom, so we know that we need to put inches on the top. This allows us to cancel out feet. And if we were to stop this problem right now, we would have an answer in units of inches. But the question is asking us how tall Tim is in centimeters. That means we'll need to use another conversion factor. Just like I did the first time, I can set up my conversion factor with inches on the bottom because I know that I want inches to cancel out. Then looking at the conversion factors I have available, I can see that 1 inch is equal to 2.54 centimeters. Because inches is already written on the bottom, I know that 2.54 centimeters must go on the top. This allows me to cancel out the units of inches. And now that inches are canceled out, I'm left with units of centimeters. So to finish solving my problem, I'm going to start with 6 and multiply by every number on the top and then divide by every number on the bottom. This gives me an answer of 183 centimeters. Let's try another problem. 1 gallon of milk is equal to how many milliliters of milk? First, we start by writing our given quantity, which is 1 gallon. And we also need to note that the units we wish to obtain are milliliters. So we know that we need to use a conversion factor, and we know that that conversion factor needs to have units of gallons in it somewhere. We also know that we want to put the units of gallons on the bottom, so the gallons from our starting value and the units of gallons in our conversion factor will cancel each other out. Let's look at the conversion factors we have available to us. You might see that 1 gallon is equal to 4 quarts. Because we put gallons already on the bottom, we know that 4 quarts needs to go on the top. This allows us to cancel out the units of gallons. Because we haven't yet obtained units of milliliters, we need to keep going. And so we need to use another conversion factor. This conversion factor will need to have units of quarts, and similar to our last step, we'll want the units of quarts to go on the bottom so that they will cancel each other out. Looking at the conversion factors that we've been given, we can see that 1 quart is equal to 0.946 liters. Because we already have quarts on the bottom, we know that 0.946 liters must go on top. This allows us to cancel out the units of quarts. But we're still not in milliliters yet, so we need to do at least one more step. And so we're looking for another conversion factor. And to make sure we don't write our conversion factor the wrong direction, it's always helpful to write the units that you need to cancel out directly on the bottom. So we know that we want to cancel out units of liters, and so we know we need a conversion factor that has liters in it, and we'll write the liters on the bottom. Looking at the list of conversion factors that we're given, we see that 1 liter is equal to 1,000 milliliters. And because liters is already written on the bottom, we'll write 1,000 milliliters on the top. This allows us to cancel out liters. Now, in order to finish the problem, we'll take our 1 and multiply by all of the numerical values on the top of our fractions, and then divide by all of the numerical values on the bottom of our fractions. This would tell us that 1 gallon of milk is equal to 3.8 times 10 to the third milliliters. Now, looking at the conversion factors given, you might have noticed that different conversion factors could have been used to solve this problem, and you are exactly right. Dimensional analysis is a process used to convert something from one set of units to another, but there's no one correct path to get from one set of units to another. As long as you use appropriate conversion factors, there's often many paths you could take to arrive at the correct answer. Let's try this problem again using different conversion factors. Again, we start with 1 gallon. We know that we'll need to use a conversion factor and that we want gallons to be on the bottom. And the only choice we have from the conversion factors that we're given here is that 1 gallon is equal to 4 quarts. So we put 4 quarts on top of our conversion factor, and that allows us to cancel out the units of gallons. In choosing our next conversion factor, we know that quarts needs to go on the bottom in order for the units to cancel out. But you might have also noticed in our conversion factor choices that 1 quart is equal to 4 cups. So for this conversion factor, we have quarts on the bottom, and we'll put 4 cups on the top. This still allows us to cancel out units of quarts. If we were to stop our problem right here, we would arrive at an answer with units of cups. And because the problem is asking us for milliliters, we need to go one more step. So again, we'll use another conversion factor. Cups is the units that we want to cancel out, so we know that we need units of cups on the bottom. And then looking at our conversion factor choices, we see that 1 cup is equal to 236.6 milliliters. And we'll place the 236.6 milliliters on top. This allows us to cancel out the units of cups. And to arrive at our answer, we'll start with 1 and multiply by all of the numbers on the top of our conversion factors and divide by all of the numbers on the bottom of our conversion factors. And what you'll notice is that you end up with the same answer of 3.8 times 10 to the third milliliters, which lets us know that although one path may be more efficient than another, there are often multiple correct ways to solve a dimensional analysis problem. Let's make things a little more complicated. If a space shuttle can travel at 17,000 miles per hour, how many meters per second does it travel? Starting with our original value of 17,000 miles per hour, we know that we need to change this set of units to meters per second. So we'll need to change the units of miles on the top to meters, but this time we're also going to need to change units of hours on the bottom to seconds. And so we'll change each of those units separately. Let's start with what we already know how to do and convert miles to meters. We know that we'll need to use a conversion factor, and in order for the units of miles to cancel out, we'll need to write miles on the bottom. We can then choose an appropriate conversion factor. 1 mile is equal to 1.609 kilometers. Because miles is already written on the bottom, we know that we have to write 1.609 kilometers on top. This allows us to cancel out the units of miles. Then we choose another conversion factor to convert kilometers. We know that in order for kilometers to cancel, it must be written on the bottom. And then choosing an appropriate conversion factor, we can see that 1 kilometer is equal to 1,000 meters. And because kilometers is written on the bottom, 1,000 meters will be written on the top. This allows us to cancel out the units of kilometers. If we were to stop this problem now, we would have units of meters per hour. But since our question asks for meters per second, we now need to convert units of hours on the bottom to seconds. So we're going to need to choose an appropriate conversion factor. But because we want to cancel out units of hours and it's on the bottom, we need to have hours written on the top. Because remember, units that are the same on the top and the bottom can cancel out. Looking at our conversion factor choices, we know that 1 hour is equal to 60 minutes. And because we already have 1 hour written on top, we know that we need to write 60 minutes on the bottom of our conversion factor. This allows us to cancel out units of hours. And to convert from units of minutes on the bottom, we need to have a conversion factor where minutes can be written on the top. We also know that 1 minute is equal to 60 seconds. So we can write 60 seconds on the bottom, and now because we have units of minutes on the top and bottom of our dimensional analysis problem, the units of minutes will cancel each other out. And now if you look at the units we're left with, you'll see that we have meters on the top and seconds on the bottom, which is what our question is asking us for. So to finish solving our problem, we'll take 17,000 and multiply by all of our numerical values on the top, and then divide by all of our numerical values on the bottom. And we'll come up with an answer of 7.6 times 10 to the third meters per second. Thank you for watching Chemistry Solutions. We hope you enjoyed this tutorial.